When we are looking at a graph to figure out the slope, kind of the steepness, we're always going to be thinking that the slope, m, equals, and you've heard this phrase a million times in class, rise over run. The only thing that I think is really tricky with these graphs is trying to find a good point, and by that I mean something that's perfectly on a point of intersection, as opposed to something that's close but doesn't quite go through. So even this is probably not a good point. We want to be really careful with that. The other thing to pay attention to is whether or not the slope is positive or negative. So positive means that from left to right, like I'd read a book, it goes uphill, it's increasing. Negative would be from left to right, it's going downhill or it's decreasing. So if I look here, this is a negative slope. Left to right, it's going downhill, it's decreasing. So I'm keeping that in mind. I know that my m is going to be negative. From there, I'm going to really carefully find good points. This one is perfect. It hits right at 1, -3. Doesn't work, doesn't work. I kind of keep skimming until I find something that looks close but not quite. And if I go till here, I find another good point. So what we want to be really careful to avoid is just picking something that's closer but isn't quite right. From there, we practiced in class drawing slope triangles to help us count. So I'm going to start by just using these straight lines to get me from one point to another. From there, my rise is 1, 2, 3, 4, 5, 6, 7. So I'll really carefully label my rise. And in this equation, my rise is 7. So now all I have to do is find my run. Since I'm going backwards, we want to be careful that that's a negative direction. So if I count 1, 2, 3, 4, I'm going to actually label this as a run of -4. If I went backwards or if I went down, I rose down, those are negative directions. My run was -4. 7 over -4 can't be simplified, so we're done with calculating that slope. Some people think they need to rewrite it as a decimal or as a mixed number. This is a clear rise over run, so that improper fraction, as long as I can't divide anything out, is actually good to go. For the next problem, if I'm given a choice and I want to calculate, we're going to use that slope formula, where m equals y2 minus y1 over x2 minus x1. So this is essentially saying the same thing as rise over run. Find the change or the difference, subtraction in your y values, over the change or subtraction difference in your x values. We found it helpful in class to start by just giving ourselves the basic setup. I know there's a fraction bar. I know there's subtraction, and I'm going to write all of that first. From there, it's helpful to kind of give yourself the reminder that ordered pairs are always x and then y. X, and then y. So I'm going to start by finding my y values and putting them up top. I could do 9 minus 1 or 1 minus 9. Kind of first instinct, I think 9 minus 1 sounds easier, so I'm going to do that. All these numbers do is give us an order to work in. If I did 9 minus 1, I have to do 6 minus 7. I have to go in that same order for my denominator. Now I'm going to simplify. 9 minus 1 is 8. I'm careful with these signs. 6 minus 7 is -1. I'll be able to simplify. 8 divided by -1 is -8. So I have my right answer. If you look at the options, it's really trying to trip you up that maybe you make a sign error, or if you get a fraction like this that you flipped and you had your x values up top. It's an easy mistake to make because normally we do work with x and then y. So writing down the formula every time, filling in the blanks, labeling points are all really good strategies. The other thing you might do if you're really uncomfortable with this formula is draw a really nice sketch and just do rise over run like we did on the graph.